Hello, and welcome to the Soils and Engineering Laboratory of the Department of Geology and Environmental Science, James Madison University. I'm Professor Scott Eaton, and today we will give a demonstration of the operation of the Casa Grande device, otherwise known as the liquid limit device, in determining the liquid and plastic limits of the soils, that is, the Atterberg limits. Today we'll be using the Casa Grande device and a grooving tool shown here. We also have a mixing dish and a frosting spatula. We'll have some deionized water and some tins to put our samples into, a cloth for keeping things as clean as possible within reason, and of course a glass plate and samples. First thing you're going to want to do is to pre-weigh your tins and also to weigh out roughly about 100 grams of soil. Sometimes laboratories pre-dry their soil to make sure they have zero moisture content. For our lab, we will just go with air-dried soil in the laboratory. And it doesn't have to be exactly 100 grams, but that's a good place to start. Now be sure that you pre-weigh your tins, otherwise known as tares. This is a very important part of the procedure because without this knowledge, it's very difficult to determine the dry and the wet weights of the soils after the fact. In some laboratories, there's an issue with the air handlers blowing down from above. Many of the balances have a partially covered ring that will minimize some of the interference you might be receiving from the blowers. The first test we're going to do here is the plastic limit test for the Atterberg limits, one of the two parts for that. And what you're going to do is to work your soil such that it has the consistency of silly putty. And the goal is to create a thread that is approximately 1/8 inch diameter, similar to that pin that you see in the far corner, right corner there. And what you'll do is to roll your sample back and forth until it reaches just that diameter in which it begins to break. And when it breaks at that diameter, you have reached the plastic limit. If at first you get down to that diameter and you haven't broken it, restart and do it again. And with the same sample, you will eventually have something that looks like this, where it's ready to break. Take these samples, put it into your pre-weighed tare, cap it for now, and then put it in the oven. Clean and adjust the liquid limit device to fall exactly 1 centimeter. Use your grooving tool as an indicator for that 1 centimeter. If your unit is out of adjustment, adjust the brass screws and recalibrate. Prepare about 100 grams of -40 soil. Add this to your mixing bowl. Add deionized water such that you create a paste that has the viscosity of frosting. place the paste in the liquid limit cup to about 1 centimeter maximum depth. The paste surface should be approximately level. Most of your paste will be in the lower half of the bowl. Cut a groove into the paste with the grooving tool, being careful not to cut the brass cup. You may need multiple passes with the tool, but when you can see a continuous brass seam at the base, then you know you have done a good job. Turn the handle to produce 2 blows per second until the separated halves flow together for a minimum of 1/2 inch. Count and record the number of blows required to attain this distance of closure. Repeat this step for 3 more trials, adding enough water to your original mix. You must have at least 1 test of over 25 blows and 1 test under 25 blows for a total of 4 runs. Now take your pre-weighed tin and take about 1/5 of the sample. This will be your moisture content for the number of blows you had for the liquid limit. Put a cap on your tin to minimize the evaporation for drying later. Repeat this procedure 3 more times so you have 2 values above 25 blows and 2 values below 25 blows. 25 blows is what you're after. Now it's time to weigh our samples before we dry them for 24 hours. Once you've weighed them, go ahead and open the oven, take the caps off so the moisture can evaporate, and put your samples inside the oven to determine the amount of moisture within each of your samples. It's time to weigh your samples after 24 hours to determine their moisture content. Extract your samples from the oven and let them cool for about 5 minutes. Carefully touch them to confirm they are okay to pick up without burning your fingers, and let's weigh them. The difference in the weight before and after drying is the weight of the water, and the difference between your original measurement and this measurement is the weight of the dry soil. That's your moisture content. When possible, recycle your soil so it can be used in the future. Of course, that's not all. Now we need to clean up. Always want to leave your apparatus at least as good, or if not better than you found it. Take your time cleaning each part of the Casa Grande device as well as the utensils and the glass plate. Be sure to dry these samples to minimize oxidation and rust. Put them back when you are done. This concludes our overview of the procedures for the Atterberg limits using the liquid and plastic limit testing apparatus, and I hope you've enjoyed this presentation.